Hey guys, so this is just a quick demo walkthrough of how to use the new Ubuntu user mode bash on Windows, which is in beta on Windows 10 at the moment, to compile and run ArduPilot or the ArduCopter stuff. So I'm not going through like all the steps to enable to get the right build of Windows onto your machine and all that. I'm just going to assume that you have gotten to the point where you can run bash on Windows. You should be able to search bash and it should resolve to um, win-sys32 bash.exe. So I'm assuming you've gotten there. And then the first time you start it, it will actually download um, the, the file system that it needs. So I'm just going to do that quickly, and then um, yeah, I'll give a walkthrough of how to set up this stuff so that you can compile the ArduCopter code base on this. All right, so I'm at the point where everything is set up, and as you can see, running running bash on Windows like this, it gives me access to the Windows C drive through a mount point. But what I'm going to do is just use the normal root, which is currently empty. And as far as I know, you won't be able to CD into a mounted drive and compile the ArduCopter code from there. Say if I had like C dash ArduCopter whatever, I wouldn't be able to compile it that way. So if you are working on or if you're editing the source code in your Windows environment, you probably need to set up some copy rsync or whatever to bring that code into the Linux file system and compile it there. So as far as I know, at least. So anyway, what I need to do to get this running in first and foremost is set up Git. And then OK on that. Okay, so I'm just going to make myself a directory called drone. Oh, so in here, I'm going to get clone. Yes. Get. All right, so now that I've cloned the ArduPilot code down, the normal thing I would do on a regular Ubuntu system is to head into ArduPilot tools, scripts, and then execute the what's it called? Prereq script. The install prereq Ubuntu sh. Now that script is not going to work on this because the script basically tries to do some stuff using some commands that are not yet available on this. So what we need to do is to edit this slightly to get it running. So what I've done back in Windows, I have the ArduPilot source code here as well. So what I've done is to edit the install prereq script. So I've made the following modifications. The apt-get command, as you can see, it installs references variables which are called out up here. So what I've done is that I've just commented that line out, and then I've made a new one where I install base packages, CTL packages, and px4 packages. So I'm skipping the last two ones. So that's one modification. The next one is that I have commented out the user mod. And the reason for that is that, as far as I know, we don't have a dialect group. In fact, I don't think we even have user mode in this build, so that's not going to work. And then the last one is that I've commented out the apt cache command on line 94. So I have this one saved in my Windows version of the repository. And obviously I could bring up VI and just edit this directly in Linux, but you don't want to see me running VI. So what I'll do instead is that I'll just copy it through the mount. Now, as you can see, this is, or you can't see it, but this code is living on my D drive, document scripts, run stuff, ArduPilot. So I can get to that by using mount d scripts, run stuff, ArduPilot tools, scripts, install Pyrex Ubuntu, and I'm just gonna copy that to run ArduPilot tools, install Pyrex Ubuntu. So I've basically just taken these modifications and copied them into my Linux folder. Right, so I should be able to run this now. As far as I know, it's pretty important that you sit outside directory when you run that script. So I should be able to just copy that stuff like that. And it should start configuring the packages that I need and also some other modifications to my system. So this is going to take a little while probably. So 0.5 gig of files, yes to that. Oops, that failed. I'm going to try and just run it one more time. All right, looks like it came through on the second time. Not sure what happened there or if I'm missing something. So the last step of the install Pyrex script is actually to cd into the Git repo and update all the submodules, which is the last stuff that's been going on here. So anyway, at this point, I should actually be able to compile the source code. So I'm gonna choose ArduCopter. And then normally I would be able to hit make or type make and then hit tab twice to get the different what do you call it, build targets. That doesn't work here. If I just type make, I get those alternatives. And what I'm going to do here is just to build a software-based simulator. So I can do make citl, and that should kick off the build itself. All right, so it looks like it has compile the code. I'm getting some warnings up here, but as far as I know, those will happen anyway. At least I've seen them before. So that means that at this point, I should be able to basically run the ArduCopter ELF model quad, quad. And there it is, listening. So that seems to have gone all right. So what I can do next is, which is more exciting than compiling the code, at least for me, is that I'm basically doing development using the Python drone kit stuff, which means that up until now I've had to basically use a Linux VM for the software in the loop simulator and then run some code on my Windows machine. And on top of that, I also like to use the Flightgear Simulator just to get some visual representation of what the drone is doing. And typically, I don't want to do that inside of a VM because the graphics performance would suffer. So I'd like to have that in Windows as well. So I thought I'd just show quickly how I'd go about setting that up to connect all those dots. So this is how I normally do things. I start the ArduCopter software in the loop simulator with a quad model, and I set the home location to a field that is just over, yeah, near where I live. Starting that, and I can actually check that using Mission Planner. So this is Mission Planner in Windows. Now, if I was running the software in the loop simulator on a VM, I would need to know the IP address of that VM. But since this is Bash on Windows, it doesn't have its own IP address. It's actually sharing the networking stack with my Windows machines. Everything is basically localhost or 127.0.0.1, and the first instance should be 5760. So see here we have a connection, and then here it has indeed started up on that field just outside of town. So that's looking good so far. Now, if I wanted to, I could try and run mavproxy connecting to my CITL instance as well. And at this point, I guess I can choose between running mavproxy inside of Linux or inside of the Bash on Windows instance or outside here in Windows. So let me go ahead and do the latter. Okay, so it turned out I actually didn't have mavproxy installed. So now that that's installed, I can do like this, I guess. And then I can do Python mavproxy. Yes, okay, good. So what I need to do is to start mavproxy and then use master equals TCP and then some other port like 5762, 5762, and then that should connect to the same instance that my mission planner is on. Let's see, where was I? Here, I think. So I can do mode guided. Okay, so what I had to do there was just to do parm download, and then I could do parm set arming check 0. Now at this point, I should be able to set mode guided, and that should result in 0. And as you can see, mission planner is updating as well. So at this point, I should be able to do arm throttle. There you go. And then take off 20. Yeah. So that's basically running software in the loop simulation on Bash for Windows inside of the Ubuntu user mode, and then running all these tools outside on my regular Windows box. Now, the last thing that I wanted to show off is to run the Flightgear Simulator as well, which I can do. So the Flightgear is most easily started using this FJ Quad View BAT. So the only thing I've done here is to basically just give it the same coordinates that I started my software in the loop from. So if I go to this directory, let's see, that's in tools, auto test, FJ Quad View BAT. So there it is, and let's try and land this thing using so as you can see in Flightgear here is actually coming in for landing, which means that everything is hooked up and seems to be working. So that's pretty much it, I think. The only thing to keep in mind is that you're not running inside a VM and you're not using Cygwin. Everything is on the same IP address, which makes it really easy to just yeah, hook up everything. And the reason why Flightgear is working is that when you start software in the loop simulation, it will actually output the signal that Flightgear picks up to the local host IP address. And the only thing you need to make sure that Flightgear picks that up, and you do that using that FJ Quad View BAT. It has this per meter native FDM socket, which is basically the link between software in the loop and Flightgear. So that's why that's working at all. So hopefully someone got something out of this. And like I said, the only limitation here is if you have your ArduPilot source code in Windows, you probably won't be able to compile that directly. So you need to figure out a way to copy that into your Linux instance. And also, as I said, you're perfectly able to reach it from within Linux using mntd and then whatever directory you have, or C or whatever. You just need to copy it across so that it's local inside the Linux file system when you compile it. That seems to be the thing. All right. So thanks for watching.